Hi everyone, I hope you're enjoying Touch Tomorrow. My name is Tani, and in this presentation, I'll be introducing you to materials science. Let's get started. I want to start off by first introducing myself. Like I said, my name is Tani. I recently graduated from WPI with a bachelor's degree in mechanical engineering and a master's degree in materials science and engineering. I thought I'd share with you an interesting fact about myself. I have a third-degree black belt in Taekwondo. During my time at WPI, I was part of the Integrated Materials and Processes Design Group, and within our group we conducted research to better improve our understanding of materials by combining our knowledge of material performance and properties with thermodynamics and kinetics. For this presentation, we are going to learn about materials science, what it is and why it's important, the different classes of materials and their properties with some examples of each. We're going to try and find materials from the different classes within our home and ask ourselves some questions about them, and finish up with some examples of other applications or uses of the materials we discuss. So what is materials science? I'll give you a second to think about it. According to the dictionary, the definition of materials science is the scientific study of the properties or characteristics that describe the material and the applications of the materials. Now you're probably wondering, why is materials science important? Why do people such as myself study it? Well, because materials are everywhere. They're all around us. Knowing which materials to choose when designing a new product is crucial. No one wants their cell phone breaking the first time they accidentally drop it. And because it allows us to understand why things break or fail so we can design better for the next version of a product. But what do I mean by materials? Well, to answer that, I'm going to share with you the different classes of materials and share some examples of each. There are four main classes of materials: metals, plastics, ceramics and glasses, and composites. Some examples of metals include aluminum, titanium, copper, and steel alloys. Steel alloys in particular are made up of different amounts of various metals. For example, stainless steel is made up of iron, chromium, and small amounts of nickel. Some examples of plastics include glue, Kevlar, which is used for body armor, PVC or polyvinyl chloride, and is commonly used for pipes and plumbing, and styrofoam, which we use for disposable plates and coffee cups. As for ceramics, some traditional examples include clay, quartz, which your kitchen countertops might be made of, and porcelain, like your dinner plates. A more advanced or technical ceramic, however, is zirconia, which is commonly used as a diamond replica in jewelry. The last class of materials is composites, which refer to materials that are made up of a combination of two or more materials that have different properties. When these materials are merged, they create a material with new properties that can't be achieved individually. Some examples of composites you might be familiar with are plywood, carbon fiber, fiberglass, and concrete. Let's look at plywood more closely. Plywood is a combination of wood fibers and glue. It's a composite. For the next few minutes, I want to focus more on metals, plastics, and ceramics and glasses. I want to share with you some of the properties or characteristics materials scientists use to determine which class a material belongs to. So let's start with metals. Visually, metals can be identified by their shiny appearance, like you see with coins and jewelry. Metals are malleable, which means they can be bent or hammered into thin sheets without breaking, like aluminum foil. They're great electrical conductors, meaning electrons can easily flow between atoms to produce electricity. That's why you commonly see copper wiring used for electrical wiring in your home, or metal prongs at the end of your plugs. And lastly, one of the most important properties of metals is their strength. Metals are very strong materials, meaning they can withstand a lot of force being applied, such as stretching or pulling, before they break. Of all the classes of materials, plastics are probably the ones you're most familiar with. From plastic water bottles to headphones to the bags from the grocery store, plastics are everywhere and we use them every day. Overall, most plastics have a relatively low melting temperature. That's why restaurant takeout containers can't be put in the oven, or why plastic bags start to melt and shrivel up when you place them close to a fire. Plastics are both lightweight and durable. That's what makes them a great choice for children's toys or headphones, because we want them to be easy to carry and able to withstand multiple uses. And lastly, plastics are corrosion resistant. Unlike metals, plastics don't rust when exposed to harsh environments like salt water. That's why no matter how many times you go swimming in the ocean, your goggles or snorkel won't fall apart. The last class I want to talk about is ceramics and glasses. Similarly to plastics, ceramics and glasses are also corrosion resistant. They're also wear resistant, meaning the material loss on their surface is minimal when they're subjected to frictional forces, unlike what you'd see when rubbing chalk against the ground. Ceramics and glasses have high hardness. That's why phone screens don't scratch easily by your keys or fingernails. And lastly, when looking at ceramics, you probably notice that you can't see through them. That's because they're opaque. Glasses, however, are transparent typically, meaning you can see through them. That's why they're used for windows, because light can easily pass through. So now that you know some properties of metals, plastics, and ceramics and glasses, and some examples of their uses, it's time to see what materials you can find in your home. Feel free to pause this video and go hunting for items in your house that you think can be classified as either a metal, plastic, or ceramic and glass. Now that you've found some items in your home, it's time to ask some questions. First, what classes of materials were you able to find in your home? Maybe one class of material was easier to find than another. If so, which one? Second, how do you know which class of material the item belongs to? Perhaps it was shiny or transparent. Maybe you tried pulling it apart and it wouldn't budge. Or maybe you tried dropping it to see if it would break. And third, where else might these same materials be used? Ask a parent or friend where they think those same materials can be used. Do you have any ideas? As I said earlier, materials are everywhere. Sometimes you can't even see all the different materials used in a product. In the last part of my presentation, I want to share with you some of the many applications or uses for those same materials. The 4 different categories of applications I'm going to cover are aerospace, technology and energy, consumer goods, and construction and building. Some examples of aerospace applications include jet engines, airplane wings, helicopter blades, and landing gears. For technology and energy applications, you have video game consoles, robotics, solar panels, and wind turbines. And for the ones we recognize most, some examples of consumer goods applications include children's toys, like my personal favorite, Legos, clothing and sneakers or apparel, furniture, and food packaging. And last but not least, some examples of applications in construction and building include roller coasters. Those are my personal favorite. Insulation, support beams, gas, water, and sewer lines. Before I finish, I want to share with you one specific example of how materials science is changing the world, and that is the Burj Khalifa. Thanks to advancements in materials science, structures such as skyscrapers are reaching new heights. By understanding the properties of materials and how they can be changed, materials scientists were able to increase the strength of steels and reduce their weight, allowing them to withstand greater forces and be more suitable for large structures. The Burj Khalifa, currently the tallest building in the world, stands 2,716 feet and 6 inches tall, and is made up of steel reinforced concrete and dressed in 26,000 hand-cut panels of glass. It is more than twice the height of the Empire State Building and almost 3 times the size of the Eiffel Tower. Absolutely amazing. There are many, many more applications of the materials we covered today. Every day, material scientists and engineers are coming up with new ways to use them, and even new materials. Be sure to check out the interesting videos linked on the website to learn of some more applications and how the materials are used in making some of our favorite products. Thank you so much for watching. I hope you enjoyed learning about materials science. Be sure to check out the other cool exhibits offered this Touch tomorrow. Enjoy the rest of your day.